Now, recently on the programme, we spoke to Minister Eamon Ryan about new research raising the possibility that ocean circulations in the Atlantic may reach a tipping point much sooner than previously thought. And when that happens, according to Minister Ryan, the consequences for Ireland would be dire. Now, the research he cites contains many caveats, much uncertainty, and it hasn't been agreed by everybody. So we asked Philip Boucher-Hayes to take a good look at it for us, and it turns out there is a date for the tipping point, one that is in relative terms very close. It's 2057, so 33 years hence. And Philip is here. Good morning, Philip.
Good morning.
So what may happen in 2057?
Well, what will happen is frustratingly difficult to put your finger on the specifics of, but in big broad brush strokes, all of the calculations change for us. We're currently one of the countries, we're considered to be one of the countries that will be less badly affected by climate change. Some people have referred to us as a lifeboat island, somewhere like New Zealand, that people would try and migrate to. But if what these scientists that you're about to hear from have got right, and nobody has proven them wrong to date, well, then all of those calculations change completely, and we're actually one of the more vulnerable nations in the world. You could put us into the sort of the category of one of those at-risk island nations like Micronesia or Tuvalu or the Marshall Islands. Because if things were to progress with just getting hotter and sea levels rising, well, then Ireland would be one of the less affected places. But there are wild cards in the pack. There are these tipping points, like the thawing of permafrost north of the Arctic Circle, like the melting of the Greenland ice sheet, like the disappearance of Arctic sea ice, all of which have a cascading effect and can accelerate this whole process. And the one tipping point that is most immediately of concern to us is the slowing down, the eventual stopping of the overturning circulation in the Atlantic. I've seen one estimate that was to say that if we were to turn off that overturning circulation tomorrow, just like that waters at the equator would become 20 degrees Celsius warmer and waters at the northern latitudes would become 20 degrees Celsius colder, effectively iced over, polar ice caps extending right the way down into northern Europe.
So we would be a much colder place.
I wish I could say that with certainty. I can't say that because the climate is just so devilishly complex. There are any number of different things that could happen. We get into it in a moment.
Well, you did mention something, the overturning circulation. Will you explain that to us?
What happens in the Atlantic is that warm waters at the equator travel north and west to our part of the world, and they have kept northern Europe warm on and off over the course of the last 3 million years. The last time that circulation stopped doing that was 13,000 years ago, so before human civilization, if you like. And it reached a tipping point. And over the course of 100 years, there was a new ice age which lasted for 1,300 years. That's the last time that the Atlantic circulation stopped. Because what it does right now when it's working correctly is that it takes these warm waters from the equator, they're pushed north in our direction towards northern Europe. And as they move further north, they come in contact with cold air. So that water on the surface of the sea starts to evaporate. It gives us all of the clouds and the rain that we so enjoy 250 days of the year here. The consequence of that evaporation is that the water becomes more salty. It's therefore more dense. So when it gets to a point up around sort of Norway, there is this absolutely amazing, one of the most amazing phenomena in nature, which is completely invisible to us because it's a waterfall under the water. There's 3 million cubic meters of water per second that is more salty, therefore more dense, that gets to this point, and then it drops about 2 kilometres down to the seabed. And it drops with such force and such propulsion that it moves all the way on the seabed down past the equator, down to the tip of southern America, where it rises again. But it's pushing water in front of it all the time. And that cascade, that waterfall up near Norway, is the engine of the overturning circulation. But we have, through climate change, effectively thrown a handful of sand into that finely tuned engine, because the meltwater of fresh water coming off the glaciers in Greenland and the melting of that ice sheet is screwing up that chemistry. It's no longer a saline because there's fresh water introduced. It's therefore no longer as heavy or as dense, so it's not falling with the same speed, and that is why that circulation is now slowing down.
Okay, so if this were to happen, if this thing were to stop working in the way that it does, would it be an overnight thing? Is it like a switch?
First thing you have to do is remove the if from that sentence. We have to start thinking about when. The when is frustratingly hard to predict. The official consensus science around this, the IPCC, says very little possibility of it happening in the 21st century, maybe the 22nd century, maybe even the 23rd century. And no, it doesn't happen overnight. It's not like that Dennis Quaid movie, The Day After Tomorrow. It doesn't happen within the space of the running time of a 2-hour movie. It happens over the course of decades. And what happens is also frustratingly vague. It is a simplistic interpretation to say that we would become like Newfoundland because we're on the same latitude as them and they don't benefit from the warming waters of AMOC. Some people say that there will be a hell of a lot more rain. Others say our northern shores could ice over. Some people say that we would be talking about -5 degrees in summer, -10 degrees in winter. I think it's safe to say, though, it's going to become chaotic, an awful lot more chaotic. Producing food here is going to have to change. How we build our homes, how we heat our homes, how we transport ourselves around the country, all would change and would change within relatively short order.
Okay, so the scientists behind this research that Minister Eamon Ryan was talking about and that you've examined now, they try to pinpoint this date when this might happen.
Somebody in the European Commission, in their wisdom, decided that it would be good to try and be a little bit more accurate about this date. It would be helpful. So 50 scientists from around Europe were gathered together to look at all of the tipping points, the permafrost, the Arctic ice, Greenland ice sheet, and AMOC, the overturning circulation. And the co-lead of that project, the scientists, is a Professor Peter Ditlevsen from the University of Copenhagen. He's a maths physicist and he's a climate scientist. And he, when they were divvying out the various tipping points that they were going to examine, he said, OK, I'll do AMOC. And there is frustratingly little data for somebody
AMOC
like...
being this phenomenon.
I beg your pardon.
No, you're fine. It's just
Atlantic Meridional Overturning Circulation. That's the last time that I'm going to say that. We'll just refer to it as AMOC now. But it is that circulation that I'm talking about.
It's the machine.
From north to south. So he took on this job for which there's frustratingly little data to help him pinpoint a date for when the tipping point might happen. So he turned to statistics, he turned to probability, he designed a very sophisticated computer model, he put all of the data and a couple of assumptions into it, and rather than throwing back a date that confirmed what the IPCC had been saying up until this point, at some point in the 21st century, it actually threw back dates that were much closer to where we are now. And there was one date that just kept on coming up again and again and again, 2057, just 33 years from now, a point where your children and my children would probably have children of their own who would be in national school. So it really is, in geological terms, the blink of an eye. And he was confounded by what he found. He was shocked, obviously, by what the computer model was saying to him. So he said, I need to turn to somebody to help me prove or falsify this. Very fortunately for him, his little sister, a woman in her 40s, but somebody who's 4 years younger than him, is the professor of statistics in the University of Copenhagen, a very accomplished academic, Suzanne Ditlevsen, and he passed on the research to her. So when I talked to the two of them on Wednesday, they both told me about what a surprise it was to them that the computer model kept on throwing back this date of 2057.
So all models agree on the way it's supposed to happen, but they're not all agreeing on when it's supposed to happen. So it came as a big surprise to me that the result from analyzing the observations would give a collapse that was so much closer to present time than the models. And that big surprise, of course, made us. I mean, that was when I involved Susanne in this also. That now we really need to underpin this result very much because it's a surprise, and it's a worrisome surprise.
How many times did you run the computer model? How many times did it keep on spitting back out this answer, 2057?
We ran the model many times. And we did corrections, adaptations, trying out, doing other stuff, but all the time returned to something mid-century. So, of course, the exact date of 2057 should not be taken completely seriously, because a collapse is not something that happens at a particular hour of a particular day of a particular year. It's something that happens over a longer time. But of course, running these models and trying out different methods, it was all in this century.
Peter, I would imagine that when you ask a question and come up with an answer that is so completely different to the answers that everybody else has, that there must be a temptation to feel, no, I'm wrong about this. But did you feel that you had a responsibility to share this information precisely because it was so different to what the consensus opinion was?
I think it's especially important that when you get something that's outside the consensus, that you bring it forth and bring it into discussion. And to be honest, I had not expected this enormous attention that came to our work. I had thought that this was like another stepping stone in the whole field with other researchers and so on. And it also is. But of course, this got so much attention because it cannot easily be proven wrong. And that adds to the seriousness of the finding.
Peter and Susanne Ditlevsen, and we should say that not everybody agrees with their findings. Philip, that's an important point to make.
No, and it's one that he has qualified there by saying nobody has yet proven them wrong, but their findings they drew huge controversy initially in this scientific community. Many people saying, no, you can't possibly be right. So the whole of their study is undergoing a really rigorous process of peer review, and they are constantly reviewing it themselves. And nobody has as yet been able to say, no, this is where you have gone wrong. So the science they're finding at the moment stands, and it is an absolute game changer for us.
Well, and can we talk about what that might look like?
Again, I'm afraid because climate is just so complex, we have to be ambiguous about this, but it is going to be chaotic. It is going to be a really big change. When you consider that, like right now, we are the second most food secure nation in the world. We still import something like 50% of our calories into the countries, but we're in a particularly advantageous position. But if you change things by 2 or 3 degrees, if you introduce a few more millimetres of rain every day, all of those calculations start to change. If indeed you are talking about getting 10 degrees colder in the winter months, as some of the projections suggest might happen, well, you're solving the tourism problem that was your previous item, because nobody's going to want to come to this particular part of the world if that is the case. So there's a need, obviously, for a huge amount more research and greater consideration of what's happening here, of what the Ditlevsens have produced. But surprisingly, governments of Europe are not throwing money at them. So I asked him as a sort of a final question, I asked Peter Ditlevsen, was it really incumbent on countries like Ireland to pay much closer attention to this research because we were going to be more affected by it than anywhere else?
Yes, obviously. Obviously, you will be very much affected by such a collapse of the AMOC. This is something that you really cannot adapt to in the same way as you would adapt to global warming. If a collapse of the AMOC should happen in such a way that, say, Irish agriculture would be like doing agriculture in northern Norway, then this is a full collapse of the economy. And that's something you cannot really adapt to. You have a fire insurance on your house. Everybody has. And very few people, fortunately, have to use that insurance. Which means, of course, that if a house burns down, the insurance company has the money to rebuild it. But if the whole country burns down, no insurance company can afford that. So you're looking into a different scenario there. And just the fact that you have this risk of such a severe collapse, I think would make you willing to spend more of your resources on preventing that.
Extraordinary stuff there from Peter Ditlevsen, who spoke to Philip Boucher-Hayes, talking about a full collapse of the economy. That's the AMOC phenomenon, which we will keep an eye on. As Philip explained to us, it's going through a very rigorous peer review at the moment, so it's worth paying close attention to. We'll be back after this break.
Text 51551 today with Claire.